Hello everyone and welcome to today's presentation on reversing a linked list. In this session, we will discuss the algorithm, its implementation, and how it works. Let's dive right into the topic. Our task is to reverse a singly linked list and return the reversed head. The input is a singly linked list where each node points to the next, and the output will be the same list with the nodes in reverse order. Let's look at a few examples. Given the input 1, 2, 3, 4 and null, the expected output would be 4, 3, 2, 1, null. This problem is essential because linked lists are commonly used in various algorithms and knowing how to reverse them can help solve many complex problems. Before we proceed, let's review the key concepts. A linked list is a data structure in which each node contains data and a reference to the next node. Reversing a linked list means altering the next references of the nodes so that the last node becomes the first and the first becomes the last. To reverse the linked list, we use an iterative approach. We maintain three pointers: prev, which initially points to null and will eventually point to the previous node as we reverse the list; car, which points to the current node we are processing; next node, which temporarily stores the next node to avoid losing the list reference during the reversal process. By iterating through the list, we adjust the next pointer of each node to point to the previous one, effectively reversing the direction of the list. Let's break down the algorithm steps. First, we initialize three pointers: prev equals to null, car equals to head, and next node assigned null. Then we iterate through the list. In each iteration, we store the next node assigned current node, current.next. Reverse the current node's pointer and move previous and current one step forward to continue the process. Once we reach the end of the list, prev will be the new head of the reversed list. Here is the code implementation of the solution in C++. This is a simple iterative implementation. We traverse the list once, updating the pointers to reverse the list. Now let's discuss the time complexity. Since we only traverse the list once, the time complexity is big of n, where n is the number of nodes in the list. For space complexity, we only use a constant amount of space for the three pointers, so the space complexity is big of 1. This is an efficient solution. There are a couple of important edge cases to consider. Empty list. If the input is null, the output will also be null. Single node list. If there is only one element, reversing the list will result in the same list as there's nothing to change. In conclusion, we have successfully reversed a singly linked list using an iterative approach. This solution runs in linear time and uses constant space, making it both efficient and straightforward. That's all for today's presentation. Thank you for your attention.